John Black, super chemist. We're gonna make some iron 2 sulfate today. We got on the left there 30 grams of iron steel wool, and on the right there we got 125 grams of copper sulfate pentahydrate. First thing I want to do is dissolve that copper sulfate into some water. So I microwaved it for two reasons. One, to help dissolve the copper sulfate. It was taking forever. And two, I'm hoping it helps the reaction go forward. Seems like it's heating up by itself, man. As I put it in, I spread it out so it's, I don't want to put it in like a ball like that. If you notice, the color of the liquid is starting to turn from blue to green. Thing is like snap, crackle, and popping. You can see all that copper. Must be exothermic because it's really heating up. So I'm just gonna stir it, and there's carbon in there also. So all right, so it's been about a day, so I'm gonna filter this. Looks like it's green now. Well, this is one of the reasons why I hate this reaction. As you can see, there's a bunch of crap in there. Even though it looked like it was nice and clear when I filtered it, now it has a bunch of that's copper metal. I'm guessing. So I'm gonna filter it again. This time I'm using a frit funnel, fritted glass funnel, so it should help out. And I got coffee filters in there too because that stuff gets stuck in the frit. It does look like it's coming out clear, but it looked like that last time too. Well, there it is. Green, nice and clear after filtering it. I'm just gonna put this on the heater and let it crystallize. Well, I just want you to see the color of it. This is after filtering it about 4 times. Every time I filter it, it looks so nice and just clear green. And then after I put it on the heat for a while on the radiator, next day it got brown crap all in it. So I'm filtering it again. I just wanted you to see how crappy it gets. It it's all brown now, but when I before I picked it up, it was all on the bottom, just like a precip. Now look at that. That's pure, clear green. There's no precip, no copper, no nothing in it. I bet tomorrow when I wake up, there'll be copper in it. As you see, they're pretty good crystals, but look down here. Well, after I filtered the crystals, I tried to wash the copper off, but basically I had to use so much water, ice cold water, that it took the crystals away too. So that kind of defeated the purpose. I could have recrystallized it several times, each time getting a little bit more copper out, but I wanted to do something faster and better. Well, this time I boiled it. I gotta try something different here. See, maybe the heat seems to get the copper to come out, so I gave it a bunch of heat. You can see it's clear and it's green. There's no brown in there. Look up here, and this is after this is 20 million times I've filtered this. See, nothing at the bottom. Well, as you can see, I got some good crystals, but I still, up on top, look at that, got some brown up there. But I got most of the brown out, and basically I got it down to where I can just wash it after I filter it, and hopefully it'll be nice and green. As you can see, it's like slush. So I'm just going to squirt it down with some really cold water. Just keep that vacuum pump on till it dries. Here's the actual crystals. As you can see, I didn't get great yield, but most of it I'd filtered out, and it got in the filter paper. I started throwing away quantities of liquid that had the brown stuff in it. If I had done it the way I said to do it, which is to boil it and just keep boiling it till you get and filtering it till you get that copper out, I wouldn't have such a loss. And the next time I do a video, I'll show that. All right, here are the crystals again. This time they're anhydrous. I dried them out, and that's why they're white. Usually I don't show that since I had such a little bit. I figured I'd dry it up and let you see. Instead of it being green like it was, look at that. It's all white. I got it labeled, put it in a container. It's 15 grams. That's 1/10 of a mole. I should have got 5/10 of a mole, but I had to figure it out, and then in the process, I lost a lot of my product, so I only got a 20% yield. The crap I filtered out and extra water that I washed the crystals with. I'm going to recrystallize that, and then I will save it for the next time I make some, and I'll throw it into that so I can recrystallize it again a second time. It'll be nice and pure then, and that way I won't really lose anything. I did find out what to do with this, though. I understand now how this works. And next time I do a video with a metal displacement reaction, I will show, it'll be a lot better. This was a miserable video, although I'm glad I did it because I finally understand how to get rid of that copper. Basically, I tried everything, tried cooling it, tried heating it, tried not heating it, tried just letting it settle. But it just comes out a little bit at a time. The only way you can get it to really come out good is to boil it. Now, I boiled this about 3 times, 4 times, and filtered it each time. I probably should have did it a 5th time. So anyways, that's the secret. You just got to boil. I boiled it 10 minutes each time. Maybe instead of boiling it 4 times, 10 minutes each time, I should just boil it once for an hour. I don't know. But the next time I do a video, I'll split it up into 2 fractions. And each fraction I'll do different. One I'll just boil for an hour, and one I'll boil over and over for 10 minutes. See what the difference is. Here's my stoichiometry, as you can see. I got my mole weights right here. Here's the formula. I'm going to use a half mole, or I used a half a mole for each one. So that's 56 times a half. It's 28. Same here, 250 times a half. It's 125. So that's what I weighed out. Mixed them together. Now I should get this much in weight. Because here's a mole of that times a half. So I should get 139 grams. Now keep in mind that this is water. I mean, this is what you actually will get. This here is the water that you will get. So these two add up to that. But your salt is a heptahydrate. So that's 7 waters for each one of these. So that's a lot of weight. So that's, for half a mole, it'd be 63 grams of water, 76 grams of actual salt. Now I want you to look down here at the bottom. You can see this is another way. This is how I made chromium chloride. I put a metal in an acid, and then I got the salt of that acid, the metal salt of that acid plus hydrogen. Although when I did it, I used chromium and hydrochloric acid. So I got chromium chloride, and it released H2O gas. So I could have done it this way, but I figured I'd try it another way for you. Keep in mind also that you see this letter C up here. That's because this is steel, okay? Steel wool, not iron. And I don't know what that means. I mean, I know it means it has carbon in it. I don't know how much though, but I'm going to guess at 5%, probably carbon, maybe 1-2%, most 5%. I'm guessing. Uh, so this is actually wrong. We actually put a little bit too little in there because if this I weigh out 28 grams, I'm only going to get 95% of it is iron. Now I'd rather have this all react and have copper, carbon. Might as well throw a little bit of iron in there as byproducts, right? Because you already got crap in there anyway. But if I don't put enough and I have too much copper sulfate, when I get done, I'll have copper sulfate and this salt, two salts inside the water. And even though this will be a lot, and I can easily crystallize it out, I would prefer to give a little bit extra of this iron. So as you can see, I divide that by 295, because maybe 5% of it is carbon. I'd end up with 30 grams. Go to completion, and I should have no blue color in that water. All right, I want you to understand something here before I go. This isn't just how to make iron 2 sulfate. This is how to make all metal 2 sulfates. Or not all, but a lot of them. Look at this list here. Now, this is the top of the list. This is the bottom of the list. This is your reactivity list. Now, if you're at the top of the list, you're really reactive. If you're at the bottom of the list, you're not reactive at all. And think about it. Gold isn't reactive. Silver isn't reactive. We know this, okay? We know that gold will just sit there and never turn into gold rust. But these metals here, I'm sure you've seen videos where they throw sodium or potassium into water and it blows up or it, catches on fire or whatever. That's because it's so reactive. You won't find this first list here. You won't really find those metals free in nature. I mean, when you get down to magnesium, yeah, sure. That's where the changeover comes. But all these will react with water, including this one, if you heat it up and boil it. Even in cold water, it reacts really, really, really slow. So these you won't really have free, and I wouldn't suggest you throw them into water, okay, to do this replacement reaction like I did. This list, or let's go to this list. This list is none of it's reactive. So you're not going to throw gold in and have it replace another metal. You know what I mean? So basically, you can make all of these with copper sulfate. Meaning if I throw zinc into copper sulfate, I get zinc 2 sulfate. Same with iron like we did. And that's why I didn't do it with chromium, was because of this. I'm not sure exactly how that works out. I might need a sulfate where the metal is in an oxidation state of 3. I think if I throw chromium into the copper sulfate we're using, copper 2 sulfate, it will make chromium 2 sulfate. And that is not what I made. I made chromium 3 chloride. So that's a chromium 3 salt. I think this will make any of these, and you can have yourself a metal 2 sulfate by doing the same experiment. As long as it's one of these, I believe it should work. And you can do that with anything. If you have copper chloride and you put any of these in, then you'll have a chloride. If you have, you know what I mean? No matter what you have, it's going to replace the metal. This metal would come out of solution. This metal would go in and replace it as a salt. Also remember, never forget, science is great.